Ismael Bullialdus was a famous astronomer and mathematician during the 17th century. He published several books, and was an active member of the Republic of Letters, a scholarly exchange of ideas during the 17th and 18th centuries. He is most well known for his work in astronomy, and his most famous work is his book titled Astronomia Philolaica. An early defender of the ideas of Copernicus, Kepler and Galileo, Ismael Bullialdus is known today as the most noted astronomer of his generation. He was also known for his mathematical works and his active involvement in the Republic of Letters as a historian, classical scholar and philologist. Ismael Bullialdus was the second born to his two Calvinist parents. His older brother was originally named after the father Ismael, but only lived to the age of 3, and therefore his parents gave him, the second born, and only surviving child, the father's name. His parents were Susanna Motet and Ismael Bullialdus. His father was a notary by profession and an amateur astronomer who made observations in Loudun, France, Korea. At the age of 21, Bullialdus converted to Roman Catholicism, and by the age of 26 he was ordained. 1 year later, in 1632, he moved to Paris, enjoying the patronage of the de Thou family. Bullialdus worked for 30 years in Paris as a librarian associated with the brothers Pierre and Jacques Dupuy, who were working on the Bibliothèque du Roi, France's first royal library. After the death of his employers, the brothers Dupuy, Bullialdus became secretary to the French ambassador of Holland. After a dispute with him in 1666, however, he once again moved, this time to the Collège de Laon, where he worked again as a librarian. Bullialdus published his first work, De Natura Lucis, in 1638, which he followed with many more published works ranging from books to published correspondence during his time involved with the Republic of Letters. He was one of the earliest members to be elected as a foreign associate into the Royal Society of London on April 4, 1667, only 7 years after the society was founded. He spent the last 5 years of his life in the same occupation in which he started his career as a priest. He retired to the Abbey Street, Victor in Paris, and died there at the age of 89. Involvement in the Republic of Letters. Bullialdus was an active member of the Republic of Letters, the long-distance correspondence of many different intellectuals or philosophers as they were called in France, during the 17th and 18th centuries. The Republic emerged as an international community of self-proclaimed scholars and literary figures which consisted mostly of men. The intellectuals exchanged handwritten letters, published papers and pamphlets, and thought it as their duty to bring others to the Republic by expanding correspondence. Bullialdus's letters exchanged throughout his correspondence within the Republic were collected and made into the archive Bullialdus. Bullialdus's archive was not kept intact. Shortly after, or as some research has shown, possibly even shortly before his death, Bullialdus's entire library, books, manuscripts and correspondence, was dispersed. The entire archive Bullialdus was sold, which led to a century of dispersal and diversion, followed by dramatic forgery and theft incidents. Evidence suggests that the Bibliothèque du Roi, the library that Bullialdus was associated with, is a librarian in his younger years, acquired a large portion of the Bullialdus papers in some years predating 1782. After the Bibliothèque du Roi reorganized its collections, the papers it had acquired from Bullialdus were divided into what is presently the collection Bullialdus, which holds 41 volumes and over 23,000 pages. The papers outside of the formal collection include around 7,000 pages of manuscripts that can be found today in around 45 different archives in nearly a dozen countries. After much research research was done, an inventory of the collection Bullialdus was prepared, and a chronological calendar of his complete correspondence emerged. Although it is difficult to prove, evidence suggests that thousands of Bullialdus manuscripts are lost. It is not likely that the precise content or arrangement of the original archive will ever be known due to the dispersal of Bullialdus' library around the time of his death. His last known testament, dated August 20, 1691, displays no mention of his manuscripts. The relatively modern-day, makeshift solutions used in attempting to balance out the missing pieces of Bullialdus' collection's theoretical puzzle come in the way of two historical documents created by Robert A. Hatch and published in his book titled Archives of the Scientific Revolution, the Long Inventory and the Short Inventory, in conjunction with the calendar created by Hatch. These documents are the most critical historical documents in attempts to recreate the archive Bullialdus. The most famous of the known letters included in the original archive Bullialdus include correspondence with such notable names of the time as Galileo, Mersenne, Oldenburg and Huygens. Less well-known but published letters of Bullialdus include those exchanged with Pierre Desnoyers, Fermat, Gassendi, Nicolas Heinsius and Prince Leopold, among others. The majority of Bullialdus's correspondence and manuscripts, however, remained unpublished. In addition to his own letters, Bullialdus contributed in large quantity to the archives of the scientific revolution. Among Bullialdus's papers were notes and examinations of rare manuscripts. Also found among his letters were copies of his contemporaries' manuscripts which he had preserved. Arguably most notable were the 10 volumes of original autographs addressed to Pierrisque. Principal works: De Natura Lucae, Philolaus, Expositio Rerum Mathematicum ad Legendam Platonum Utilium, translation of Theon of Smyrna, Astronomia Philolaica, De Linis Spiralibus, Opus Novum ad Arithmeticam Infinitorum, ad Astronomos Monita Duo. Undoubtedly, Ismael Bullialdus's most famous work is his book titled Astronomia Philolaica. It was published in 1645 and is thought of by some historians of science today to be the most important book in astronomy between Kepler and Newton. The book widened the awareness of Kepler's planetary ellipses, however, whereas Kepler used a physical cause to explain planetary motion, and called on math and science to support his theory, Bullialdus offered an entirely new cosmology, his conical hypothesis. Bullialdus's Philolaic astronomy consists of 14 main assumptions. The assertions of Philolaic astronomy: planets have a simple motion in a simple line. Planetary revolutions are equal, perpetual, uniform. They should be regular revolutions are composed of regular revolutions. They can only be circular, or composed of circles. Motions should have a principle of equality. Since they admit of a certain inequality, the center of the zodiac must be the reference point of inequality. This point is in the Sun. Half of the inequality is attributed to eccentricity, the other to another cause which makes the planet slow at aphelion, less slow at perihelion, without disturbing the equality of motion or transposing it to some other place, whether the circle or the surface. When the planet moving from aphelion comes to quadrature on the same surface, with equal motion, it should differ from the apparent motion of the first inequality completely or nearly so, but because the other half is due to the distance the circles. The center of planetary motion must be between the points of true and apparent motion. Since the equal motion in the first quadrant is greater than the apparent motion, that part of apparent motion must be greater. Hence, from the first quadrant to perihelion, the arc described going to perihelion must be larger than the first. All revolution is composed of circular parts. The same is true of each part. Equal motion is uniform, thus the motion incoming from aphelion corresponds to the larger parallel circles, which increase from aphelion to perihelion. This equal motion does not correspond to a single circle, but to several unequal circles to which the apparent motion also corresponds. The apparent motion includes all the circles on the same surface. The motion must be eccentric and inclined. These circles follow one another in a continuous series and are all parallel among themselves. They do not overlap or enclose one another. The apparent motion forms a solid surface containing larger and smaller circles. Bullialdus's famous hypothesis, inverse square law. Bullialdus is often deemed the finder but not keeper of the inverse square law, which states that the intensity of an effect such as illumination or gravitational force changes in inverse proportion to the square of the distance from the source. Conical hypothesis. The planets, according to that astronomer, always revolve in circles. For that being the most perfect figure, it is impossible they should revolve in any other. No one of them, however, continues to move in any one circle, but is perpetually passing from one to another, through an infinite number of circles. In the course of each revolution, for an ellipse, said he, is an oblique section of a cone, and in a cone, betwixt the vertices of the ellipse, there is an infinite number of circles, out of the infinitely small portions of which the elliptical line is compounded. The planet, therefore, which moves in this line, bulges in every point of it, moving in an infinitely small portion of a certain circle. The motion of each planet, too, according to him, was necessarily, for the same reason, perfectly equable, an equable motion being the most perfect of all motions. It was not, however, in the elliptical line that it was equable, but in any one of the circles that were parallel to the base of the cone, by whose section this elliptical line had been formed. For, if a ray was extended from the planet to any one of those circles, and carried along by its periodical motion, it would cut off equal portions of that circle in equal times, another most fantastical equalizing circle, supported by no other foundation besides the frivolous connection betwixt a cone and an ellipse, and recommended by nothing but the natural passion for circular orbits and equable motions.